Welcome to part 2 of my video series, Max Learn to Weld for Beginners. Glad to have you here. Who's the target audience for the video? Indeed, this video is crafted for those who've always had a fascination for welding but didn't know where to start or what gear is required. This series is dedicated to them, and my goal is to shed some light and showcase the essential equipment. If you've just found this video, there's a part before this. I suggest you watch that first for a clearer grasp of the ideas I've previously discussed, which could be mentioned in this second part. Check out the first video segment in the top right corner. Sure, enjoy, and for all other spectators who've seen the first part, let's move on to the next part today. Can you clarify the machine's settings? What should I tweak? Sure, then we'll see how much progress we make. Indeed, take pleasure in it. As I previously stated, I highly endorse a multi-welder, priced around $200. It provides the flexibility to switch to 2 other welding processes if you find the activity enjoyable. That's one point to consider. Should I flip the arc up here or not? Electrode welding in German. Sure, you can continue with the procedure. In the middle, we have MIG welding, often just called MIG. I've previously clarified the distinction in part 1. Moving on to the second stage, we have what's known as TIG, short for tungsten inert gas welding. Essentially, I'm using a tungsten needle, which is protected by an inert gas. This stops it from burning and only generates a heated arc. I use an arc to melt the wire, which allows me to weld. However, that's another topic. I think I'll delve into it later in the series. Indeed, our aim is to either weld or employ MIG-MAG welding, hence we utilize the 0 position here, which undeniably is the objective of these 3 distinct adjustments. I can now flip on the main switch located at the machine's rear. Naturally, the initial step is to confirm that my machine is connected to the power source. Now, when I weld, I need some electricity, as you might be aware, so I always connect it straight into the outlet. If feasible, don't use a cable reel. An extension cord is a good alternative, preferably with a 2.5 square cable cross-section, implying a slightly thicker internal wire. That's why a typical white extension cord is suggested. Be mindful when buying such items. If I were to begin welding now, the initial step would be to commence right here. Boost the throttle. Next, I'd activate the machine's primary switch. Naturally, I'd have to start my procedure by grounding the wire down here to my workbench or the piece I'm working on. Once the wire and everything else is set, I can essentially start the welding process. I've got a screen here and 2 adjustable potentiometers. So, what does that truly imply? Here, I've calibrated the amperage to 144 amps, and the voltage has been set to 25.1 volts. Indeed, it's me. Handling amperage should be manageable for anyone. So, if I consume more electricity, I produce more energy, ideal for handling denser materials. When I'm welding thinner materials, I decrease my amperage even more. We'd commence with that then. That's right. Simply put, if you're new to welding and working on a project, it's advisable to begin with a low current to see how it interacts with your material's thickness. This is crucial because, in the worst-case scenario, starting with a high current could harm your workpiece, causing holes due to burning, which is undesirable. If the wire is overly cold, utilize a grinder to remove it, then restart with a marginally increased current. That's my suggestion about the amperage. Naturally, my wire speed self-adjusts. A preset curve is stored and set, so I'm at, for instance, 150 amps. For example, 8 meters of wire each minute, or perhaps 9 meters. It functions on its own, so you can. The wire's adjustment can't be done separately. All you can do is ease the stress here. Yet to be decided. This lets me define the length of the arc. Allow me to demonstrate on paper what this arc length represents. Yes, I think that's the easiest explanation. Now, what is the arc length exactly? Sure, I'll paint here. Turn on the gas valve. Here's my wire sticking out, and this is my workpiece. After I light the torch, the wire moves towards the workpiece, creating a short circuit. This short circuit then leads to the formation of an arc. This gap, from the wire tip's top to the workpiece, the range is the arc length, implying if I extend this skirt section and slightly distance my gas nozzle. Allow my cord to show here. Here, I have a larger one. Here, I have a longer arc length, indicating a higher voltage usage. Now let's ponder an extreme scenario. Is my range here truly extensive? Like I mentioned, this is it. I can modify the arc and length by reducing or boosting the voltage. Let's start with 15 volts, and we have 26 volts here. What's the purpose of this? Indeed, when welding a root or closing a small gap initially, I'd opt for a short arc, which refers to the arc length. This tool can also be used to reduce spatter if it's excessive. You might notice there's too much spatter now, and then you have the option to slightly raise the voltage and fine-tune it using the arc length. Sure, I think I'll give a practical demonstration to show you how it appears with the short or long arc. Enjoy it? I began with 80 amps and 15 volts. Currently, that's the case, and with every restart, I'm enhancing by adding an extra volt. You can observe the arc's expansion. The light and heat will both intensify, hence the increased smoke afterwards. I can also modify the seam geometry, meaning the more tension I apply, the flatter the curvature becomes. The syringe is almost empty, and I have several choices. Experiencing the excitement of achievement. Finally, it dips slightly due to excessive tension. Here, you can observe the progression from my starting point at 15 volts, moving up to 16, then 17, 18, 19, 20, 21, and finally culminating at 22 volts. You can observe the alteration in the seam. The back is progressively flattening while the front remains overly curved. As a welder, this would signal to me that my voltage is insufficient. The current is adequate, so I'd make a minor adjustment to the voltage. The highlight, I'd say, was 20 volts at 80 amps. I discovered that this was the optimal setting, and it also provided the best welding results. So it's necessary to do a bit of experimentation, usually starting with a basic plate or something equally simple. That's how you configure your machine. After that, there's no need to consult any lists or other references. That's just pointless. Because, depending on the circumstances and the kind of wire you're using, these values are bound to vary anyway. Sure, I'm going to display 3 additional pictures now, each featuring a small, medium, and large arc, respectively. Yes. So, here we are, wrapping up part 2 of this video series. In our next session, we'll dive into welding, providing guidance on the necessary steps and precautions. I'm eager to share this knowledge with you. I anticipate that this will be the concluding video in our series. If you like this, hit the thumbs up and tell me in the comments what you want to see next. Until then, I'll bid you farewell until my upcoming video.